Welcome to this UASMaster video tutorial. In this video tutorial we want to show the editing from the feature-based matching least square matching point cloud that we generated with UASMaster version 9.1, which is typically used for the orthophoto production. So in our case we will here load our point cloud by dragging here an area. We will select all the points because the feature-based matching is writing a more coarse point cloud and load this into our editor. The data itself here, as mentioned in the previous video, let's just go back here and show it here, is densified by 30 times the pixel size. So when we look here at our log file, then we can see here that our ground sampling distance here is about 4.6 centimeters, and we are only writing for the feature-based matching an interpolated DEM grid, which is here then written with 1.39, which is 30 times this value. So if you multiply 30 times 4.6 centimeters, then you will reach 1.39 meters, which is the density here of this data here. You can check this by just zooming here into the area with the wheel mouse. Then we will use the measure length distance tool. You can also find this here in the review part. Then we open here our tool options, and when we then measure from one point to the other one, we see here this is about 1.39 centimeters distance. So what we will do today in this video is loading our data, which we already have done. We dragged here a box where we selected, in our case, the whole data set. Then we started our point cloud editing, and then when we load this into the editor, the data is then available in the US edit part. So this is always needed. So all the changes we do are always done in the US edit part. And then after we do our editing, we will then again commit the data back to our point cloud manager. To check the data, we will go today through the typical tools that are used for searching for errors. So we will use the contours and search here for peaks in our contours. We will then look into some areas with the profile view, see how the points are distributed, and make some interpretation if we see here some errors too. And also with the shaded relief, where we can see in the terrain where there are undulations or not natural looking terrain shapes. It is also possible to do stereo editing in UASMaster. Unfortunately, we cannot show this here in the video tutorial, as the stereo will not be displayed in the right way. We will then select the errors and then reinterpolate the wrong measurements. The reclassification is another option when you have dense point clouds, or sometimes also to remove some obstacles out of it. We will then just shortly show how this functions. After this is done, or also this is one of the parts, but also what we want to do is go systematically through the data. So we will use the profile view, open here a box, and then systematically step through our data to search for errors in our data, and therefore hopefully we can then guarantee in the end a specific quality of height, and also assure that all the data is within a range of height accuracy for our next step, which would then be the classic orthophoto generation. You can activate the contour lines here through these buttons. You can also find them here in the display, contour lines. And for the contour lines, for quality assurance, we want to search for specific height differences, and so we can here, when we activate the contour lines, there's here a drop box where we can say I want to see 1 meter contour lines, or you can also drop it to 2.5 meter, and then we would see 2.5 meter contour lines showing us here in our data set these differences. So I will go to 1 meter back, and then we can look here through our data. We see here in this terrain here some parts, and we can then here look at this area in more detail. And this is then done by the profile view. So the profile view, you can search it from view profile area, and here we will have to make 3 clicks. So the first 2 clicks are defining our baseline, first click, second click, and then when I move my mouse we see a box that is going up and down, and when I make my third click, wherever I place it, I can place it here on up or down or in the middle, this is up to you, then we can see this data now here in our profile view. And the profile editor view is here a new tabulator, and this one I can select. I can keep the right mouse button pressed and rotate the whole part. If I'm not sure how to look at these points, I can also shade the data here, and then we see here that these points here are not looking naturally, but be aware this is overstretched. So the overstretching can be manipulated by this drop down box. I can make a 1-to-1 stretching, and then we see here this is how the points are here located. In our case here I keep automatic, so we have the maximum stretching, and now I can select these points. I can either select it in the profile view with the selection tools, so point, fence selection or rectangular selection. When I go to the fence, I can just drag a fence and then I select the points. You can also leave the shading out or on, this is up to you in this case. So then you can also add these points additionally to it. And you could also select the points here in our main view. So I can add this point here additionally also to it. When we have a selection, then we can use for these feature-based matching points a nice tool, which is then called the reinterpolation tool. We say these points are wrong and we want to place them in the surrounding of the other existing points, and this is done by edit reinterpolate selected points, and then these red selected points get a new height from the surrounding points. So then we can see how they are placed down here. Also the shading is on the fly corrected, so we see before, after, and this is then how we can here use the reinterpolation tool to place these points on a new height. Looking at the contours, this would then look here before and after. And so we could go through our data set here and check if we have points that we don't want to have in this location. You can also look at the whole part also with the profile view. And this is where the next step is. We can here step through the data. We can select here a box, define a specific size, and shade the data, keep it 1-to-1 stretched, and then we can go with the arrow keys and hit here forward or sidewards and step through the data. And when we see here an arrow in our data, we can also place the contour lines on top of it. Then we can here search for parts, for example this peak here, so we can select this peak by selecting here the fence selection tool, and then we can here select these points. After we select them, we can hit the reinterpolation button, place them on a new height, and then just hit the escape button to deselect them again and continue to the next part. And so we can go and check our data and make corrections in a systematic way where we can then directly see how these measurements have an impact. If we are not sure about an area, like for example here, we can also just select the points, and then we can go into the 2D editor, and this is where now the stereo would be a nice tool. When you have the photos, you can select them all and activate them, and then you can use here from the display function, from the viewing functions, the best fit stereo, and then you click into this area, and then you would see this area here in stereo with these two selected points, and then you can in stereo evaluate the points if they are correct or not correct. In our case also it's nice here, we can just look at the left image and we see this is here probably on top of the tree. We can also activate here the contour lines and see the whole thing in stereo, and then we can here reinterpolate the points, and then we would see now how these points are shifted in height on the correct height, and this is then also a checking functionality for us for this part. Then we can continue and just systematically do the editing on our data itself. So this is the options how you can then edit the parts of your data. Another editing option is also the shaded relief. Here in the main view you can have the shading together with the contour lines. Typically the shading is in a gray value, so the blue contour lines are not so easy to see, so you can go to the options, preferences, and change here in the layers the contour color, so I can make them red, and then of course my selection should perhaps a different color, so I make this purple, and then we see the contour lines in red. Also here in these layers you can define the thickness of the points, how thick they are displayed, and therefore this will also be an option to visualize your data in a different way. Hopefully through these editing steps you can reach then a height accuracy for your data where you would feel comfortable to say, okay, my terrain model is at least 1 meter accurate in height, and then with this data we want to continue to our classic orthophoto production. So to do this we have to bring our data back to our point cloud manager, and this is done by save and update the point cloud. Up to now you can always do undo and redo. As soon as we will save the data back to the point cloud editor, to the point cloud manager, the undo steps then are removed. So you should feel now sure that you are happy with your results, and when I say yes, then I hit save and update, then the data is removed from the editor and placed back into our point cloud manager. So when we look here in the back, there is no data anymore in the US edit, and also when you go to the US edit you see all the editing functions are grayed out, and therefore we can now continue with the next step, and this would be in our case then the orthophoto generation, the classic orthophoto generation, which we will start here from this part. The data itself here that we have changed is not stored on our point cloud last part, but it is stored in our internal database. So the internal database in this case is the DAT file, and so if you look at the clock, so this is now updated at 11:53, and my point cloud is still from 11:09. So the point cloud is only my result after the automatic surface generation with the feature-based matching. So at the moment all our data is here in the DAT file, and this DAT file data will also be used for the classic orthophoto generation. Okay, thank you very much for watching this video tutorial, and hopefully see you soon. Goodbye.